Hello, everybody. We have an unusual stream in English today, and we have a guest who is Alex. Alex, how do you pronounce your last name?
Rickabaugh.
Alex Rickabaugh from the Angular team. And today we are going to work on error handling for standalone components. That's exciting. I'm really excited to see like part of the workflow because I tried contributing to Angular once. And that was like, for me, it was like lots of pain trying to figure out Blaze and then trying to stream and Blaze at the same time, which hanged my laptop for 15 minutes. So I would love to see your workflow and generally like how you handle things.
Yeah, thanks for having me.
Yeah.
Um,
So this is one thing I'd like to know is like, so you're working on this RFC and you have this cool new process where like when you make a technical decision, you share it with the community first, which sounds awesome. So how do you divide the work? Because I see there are like multiple names on the RFC.
yeah, so the standalone effort, right, which was previously listed on our roadmap as optional ng modules. Optional ng modules is the goal that we had. Standalone is kind of the name that we gave to the actual implementation of that goal. But this project is kind of being led by one of our Angular contributors, Pavel Kozlovsky. And so he kind of, I guess, organized all of the discussions, but we had a group of people, including Igor, formerly of the Angular team, Minko, Pete, Andrew Kushner, and myself. And we spent many months just kind of in the, every week or so, we'd have a few hours of discussion, just talking about the problems around ng modules, the problems with, various ideas that we had around how to build applications without them. And all of that kind of discussion ended up converging on something we thought was a viable solution. So we tossed this idea around for a few weeks and kind of crystallized exactly what the behavior should be. And when we were confident that we couldn't think of how to break it, that's when we decided, okay, it's ready. It's time to write this up and share it with the community and see if any of them can break it. And so we had this RFC, quite a long one, actually. There's kind of a lot of different aspects to this proposal. But at the end of the RFC period, we were happy to see that like our initial instinct was correct. Nobody seemed to be able to find any fatal flaws. We get a lot of really good feedback that, evolved the design in certain ways. But I think our biggest fear was that someone would just uncover a tiny little hole in it that when you pull at that thread would just unravel the entire thing, right? But fortunately, that didn't come to pass. So this RFC is actually only half of the picture.
Okay.
So this describes kind of the core feature of what we call standalone, which is the API for actually authoring and interacting with a standalone component. There's a second RFC that'll be coming sometime in the next couple months that describes how standalone components integrate into the rest of the framework. So our goal really is for, if you're writing an Angular application, we want you to be able to do that without having to know how ng modules actually work, without ever having to write an ng module yourself. So you may still be using libraries out there that are published with ng modules and importing them, but you shouldn't have to like understand the nuances of how to write them.
And the motivation behind that is basically to simplify teaching experience.
There's a couple of different aspects to it. One of which is definitely to reduce the number of concepts that you have to learn. But also ng modules are complicated in some interesting and subtle ways. And there are some features that we will only be able to offer with standalone components because of the simplicity and the kind of different semantics that they have. So it might be interesting actually to go through a little example of that.
That would be cool. Yeah.
Yeah. Let me just open up my IDE and I can play around here. So I think I'll just jump back over to VS Code.
Meanwhile, in the chat, a bunch of people saying hi. Hello, everyone.
Hello, hello. Good morning. Good morning here from San Francisco, anyway.
There is 11-hour difference between Moscow and San Francisco, so it was a bit tricky, but
yeah, we did. I've been part of discussions around Zone.js.
Oh.
And Zone.js is maintained by a lovely gentleman by the name of Ja Lee in Japan. And I was working with him and with Pete Bacon Darwin and Yoast in Europe, and me here in California. And so scheduling a meeting between Japan, Europe, and California, like, insane. So it ended up being like 6 a.m. for me, like almost midnight, I think, for Ja, and then Pete was just having his afternoon tea.
Yeah, that's. I had some streams where I was trying to figure out Zone.js, and I got like really stuck, and I actually reached out to Ja, and he tried to help. That he was like very responsive, but because of the time difference, we would just exchange like one message per day, basically. Yeah, that was hard.
Yeah. Oh man, definitely.
Cool.
So
Okay, yeah.
I'm in some random file here. I just needed a space to be able to write things.
Cool.
So we write components in Angular, right? So I'm gonna make a component. Well, this will be our. See, it's a good way to think about this. Just make it an app component. We're gonna have some kind of template. This is our normal application component, and because we're writing ng module based code, we have to declare this component in an ng module.
So you're we see forms TS file, and we don't see you typing.
Oh, maybe I'm in the wrong. Yeah.
It might be in the wrong. Yeah. Oh, here you go. Cool. So you create a component, you create a module, you declare the component.
So let's say that we're using some library, right? And
yeah.
Perfectly all. So in our library, we also have a component. Let's make it a calendar.
Right.
And kind of the implementations of these things aren't super important. Fancy calendar, right? And it's going to have some kind of template. Okay. And again, we need an ng module. Declares the calendar component. And we're going to export the calendar component. Here in our application, let's condense these things pretty quick here. We want to use this fancy calendar.
All right.
And we know that in order to do that, we need to import the fancy calendar module, right, yes, in our app module. And so this line of importing this thing has multiple effects, right? One of them is it makes this component available in our template. Because app component is declared in the app module. Yeah. And then calendar module is imported. This template has visibility of fancy calendar. So already the ng module picture here is kind of complicated, right? There's like an arrow pointing from here to there. There's another arrow pointing from here to there. And then there's an arrow pointing from like calendar module to calendar component. And the compiler has to do actually a fair bit of work to understand what this component actually means, right? Just looking at the app component, you have no idea. You have to go and find a module that declares it, and then like collect all the imports and collect all the exported things from the imports. And when the compiler has to do a lot of work to figure something out, it also means that kind of mentally, we as developers looking at this code have to do a lot of work to figure it out. You know, one of the things is when you drop into an Angular application that you've never looked at before, it can be hard to understand where some of these things are coming from. And the language service helps you a lot there. It's not going to work in this particular context because I'm editing code in Angular core, which is a little weird. But let's make our calendar a little bit more complicated, right? So in my calendar component, I need to work with dates. And because I'm an Angular developer that values testing and dependency injection, right? I need a date service.
Okay.
I'm going to move all of the code related to dates into this date service that I'm going to inject. So we'll go ahead and write that. It's going to be injectable. Service. And so the next thing I need to do is provide this date service somewhere. And the standard way of doing that in Angular today is to put it in the calendar module providers. Right. My calendar component is exported here, and I make sure that its service is going to be available. So wherever you use this thing, you end up, it has its date service. And the user doesn't actually have to know, right? The person who's using the calendar doesn't have to know that there's this date service there.
Right.
That's kind of an internal implementation detail of the calendar, right? You just want to use the component. You don't really care about setting everything up correctly for the component. And because I've imported the calendar module in the application, right? Not just the component, but the entire module. Now this is having two effects.
Okay.
One is it's setting up the template so the thing is visible, but also it's brought that provider into our application injector.
Yep.
And so when this calendar component is actually created, it will be able to inject date service because it's provided through this.
So basically, like now in the app, you can use that service, even though like that was not the intention.
Well, yeah, if you have visibility of it, right? The library may not actually export this thing for you to get.
Okay.
But in the application, you don't actually have to care about what services Fancy Calendar needs. They're all set up for you by importing the ng module. So now let's complicate our example a little bit. I'm going to remove the import of Fancy Calendar here, right? Actually, let's leave that in place for the moment, right?
Right.
Let's say that I only need to render the calendar as like a modal dialog or something like that. And so I actually want to render it dynamically. And we can simulate that a little bit. So like load calendar, right?
Okay.
So I have some, well, we can make this a concrete example. So button, and when I click the button, I load the calendar.
Okay.
So I'm going to create the calendar component dynamically. So in Angular, you do that by injecting this thing called the view container ref, place to dynamically create components. And you can get view container ref for some particular location in the DOM, but I'm just going to inject it for convenience here. And now I say view container ref, create component, and I want to create an instance of the calendar component. So that will dynamically instantiate this component and add it to the DOM after the app component here. When this calendar component is created, it's going to try to inject the date service.
Right.
And it's going to work because I've imported calendar module here. If I don't do that, right, if I forget to do that, I can still attempt to create an instance of the component.
Right, and you'll get an error.
And I'll get an error. Exactly. So it'll be like, can't inject date service. I don't know where to find that token. You never told me about it. And, you know, you can actually end up in this situation. Let's say we want to lazy load the calendar, right? So I use import my library here. get a reference to the module, and I try to create component of module calendar component. Right? We're kind of outside of my example here. So it's common to want to be able to do things like lazy load a component and create an instance of it.
Mm-hmm. But then you cannot have the module there because that's not lazy loading anymore, right?
Yeah, if I put the module here, right, then it's like, this is forcing the module to be eagerly available. That's not what I wanted. I wanted to lazy load the entire thing. So the right way to do this, and this is not at all intuitive, right, is first I need to call this function called, let's see, module ref is create ng module ref. Probably a function you've never heard of in Angular.
I actually saw this somewhere, but yeah.
Yeah, it's not super commonly used, right? So this gets me kind of an injector created from this calendar module. And then there's an option to create component to pass in an ng module ref.
Okay. And then
so now this thing will be able to inject its service, right? Because it was created in the context of like the right ng module.
Oh, so when you create component, you can provide module. You probably can provide injector as well if
you can do, yeah. So there's, and actually I think the right thing to do here is even more complicated, which is I need to inject my ng module ref, like parent module.
In case you want to provide something which the library will use.
Well, the library may, depend on things which are in the application injector. So I think I can say unknown here. And then I have to provide the parent, which is parent module injector or something like that. I don't know why my formatter is going crazy here.
Okay.
But the point of this example, right, is it's actually really complicated to get the ng module story right when you're trying to do things like dynamically load and create components.
Yeah, and it's basically because components cannot declare their own dependencies, and that's basically what you want to fix.
Yeah, it's because to use a component in Angular, you have to not only load the component, but you also have to create this environment around it, which comes from the ng module. So the component is actually not reusable on its own, right? It doesn't stand alone. It needs this ng module associated with it in case it has providers and dependencies that it wants to be able to access. And so this was the inspiration for the standalone feature, right? Standalone is a promise a component makes that says, you don't have to care about all this ng module stuff, right? You can just create me directly and I will work in any context. That's what standalone on a component means, or a directive or a pipe.
That's
right?
cool. So
you can depend on me to be independent of any ng modules.
Cool. So basically, like one of the primary reason is dynamic components and like components not having to care about like modules.
Yeah. So if you look at the JavaScript ecosystem, right, people are getting really excited about some of these ideas around things like module federation. Breaking applications into pieces and micro front ends and loading those pieces, kind of building and loading them separately. And so this use case of like, I just want to lazy load a component that I may not have even known about at compile time, right? I didn't know that I needed to put like calendar module in my app module to make this thing work. It didn't even exist when I built the application, right? But I want to load this piece of code and render it as a component. To do that in a way that is intuitive and not and hard to screw up, right? Like this is very easy to screw up. I guarantee you most applications that do this don't get the ng module story right. One of the things people will do is they'll like inject just the injector here.
Okay.
And you'll pass this in as like the parent injector.
Oh, is that not?
They'll pass this in as the injector here or something like that. These APIs are really, and so this is wrong because you're trying to set up the module injector side.
Mhm.
And what you're actually doing is making the parent injector of this module a component.
Oh,
which
so it's a
really-
component injector, which is
Yeah, exactly.
But would
Like-
the component not have access to all the module things?
It does, but it like Angular is based around this idea of an injector hierarchy.
Mhm.
And the base of the hierarchy are the ng module injectors, and then you have kind of the component and template injectors on top of that.
Mhm.
And so if you start swapping the ordering around, things will still work, but they just might be very unintuitive.
Mhm.
You know, one component expects to be able to override a provider, and if you do something like this, then you're kind of bypassing that override.
Mhm.
And so the like in many cases, these things will still work.
Mhm.
They'll
Until
just
they
be
will stop
more
working.
brittle. Yeah, until they don't, right?
Uh-huh.
And then it takes you a solid week to debug through all the stuff and figure out why the certain service isn't behaving the way you thought it should.
Cool. Okay, it seems like the motivation is pretty clear. People in the chat are liking your picture in the background.
Oh, this thing?
Yeah, what is this?
So an artist friend of mine does these, and his thing is like 2-dimensional paintings that look 3-dimensional. And so this is actually flat, right? But
oh,
he has an effect in there to make it look like they're recessed little pictures within the big picture.
That's pretty cool. So that's just a drawing, right?
Yep.
Nice.
Exactly.
Cool. And then another. Mm-hmm.
Oh, I had him. He was visiting me one time, and I pointed at this big blank wall over my couch. I'm like, "Can you fill that?" He said, "Yep, I can do that." So
nice.
3 months later, he sent me this thing.
That's very cool. And then the other question is like, what's your choice of ID? Like we can see using VS Code. What do you think about alternatives?
Yeah, I almost exclusively use VS Code. I like it. I just find it to be very fast and intuitive for me.
Cool. Have you tried like WebStorm or other things?
Yeah, I have. And I actually do a little bit of development with JetBrains, I think, for C# and some of the other projects that I work on. But VS Code is generally my preferred IDE.
Cool. All right. So now we understand like what we are working on, and today we're going to work on error handling for the components, right?
Yeah. So let me kind of extend this example a little bit and show you.
Okay.
Let's first of all say like, okay, how does standalone components solve this problem, right? So the first thing we would do is say, let's make this library component standalone, right? And this is going to show up highlighted in red because we actually haven't made the public API yet on component. What that means is you no longer need this ng module. And this component can just say like, maybe I import some like grid component or something. This component can declare its own dependencies. It's that this component has to find an alternative way to provide its state service.
Okay.
One way of doing that might be just to add it to the component providers,
which is kind of available right now already, right?
Yeah, you can do that right now. Another way, like especially if you want to share instances of the date service across all of the different calendars, right? There's no real reason each of them needs their own provider for it. So you can annotate the injectable with provided in root. And this just says, make this thing a singleton across the entire application. So this is kind of like an automatic way of importing it into an app module.
Which is also something which is already available, right?
Yes, exactly. So by doing this, right, we are holding up the promise that we're making with standalone and saying, I am independent of any other configuration. Like you can load me and use me without needing to import a bunch of dependencies.
But also like one thing you can do now is you can have other components. But what did people? I saw there was some discussion on calling this imports, just because imports is usually something where you put modules and now you can put like all kinds of things, or is it only like components and directives?
No, so if I like, let's say this I'm using a material data table, right? I can actually import here mat table module.
Okay.
So if the thing that I'm consuming is an ng module, is exported by an ng module and not standalone, then you import it this way. So there's a bridge from the standalone world to the non-standalone world, right? You can import things which are modules. Conversely, if I was not lazy loading this component, right, and I just wanted to use it directly in my app component template, you can actually import the calendar component directly here.
Oh, okay.
So this is the bridge from the ng module world back to the standalone world. So in either direction, these things are interoperable.
Oh, cool.
And that's going to be a theme in Angular that's pretty constant as we design as we start kind of evolving the framework a bit and designing some of these new APIs, is we want to move the framework forward. We want to kind of implement the types of features that people are requesting, but we're always going to make sure there's this bridge back to the existing applications, right? No islands. We shouldn't have APIs where you kind of have to be writing a certain style of application in order to use it.
Cool. Dmitry in the chat is saying that he's gonna go and fix all the injector, like passing injector when instantiating dynamic components in the project.
Yeah, this provided in root functionality. I was the one who wrote this, and so I was the one who picked this name.
Oh, interesting. Okay.
An absolutely terrible name, so I apologize for that.
It's pretty confusing.
Yeah, and we might end up seeing like a refactoring or renaming of this at some point in the future. But the really nice thing about this functionality is this is kind of logically saying, like, I want this to be a singleton in the application, right? Place this in the root injector. But it doesn't actually require that the service be loaded when the application injector is created, right? When you're bootstrapping your application. And so that means that if you try to lazy load this standalone component, your bundler like Webpack can just take this date service and include it in whatever lazy loaded chunk there is, even though it's like logically a part of the application root. So when you put this on your service, not only do you not have to care where, you don't need a provider in an ng module in order to use it, you also give the bundler the most freedom in figuring out where it makes sense to place this code. So if it can lazy load the service, it will. It's really convenient.
Cool. And
so this is the gold standard of providing a service in Angular.
Yeah, and that's something available right now. Like, you don't have to wait for standalone components to use it.
Exactly. Yeah, you should almost always do this unless you have good reason not to. And you can even, like, if this is an interface, right? I could say, like, I want to use a particular implementation of it here. Gregorian date service. I don't know.
Okay.
So you have the same flexibility with provided in root as you do with a normal provider, right? You can use class or use value or use existing or use factory, any of those things.
Oh, cool. So you can inject a date service and you get the Gregorian date service. Or you could have like a factory which will be lazy loaded only when like it's actually used.
Exactly.
Cool.
So yeah, that's kind of how the interop with ng modules work. So let's talk a little bit about what I wanted to achieve today in terms of code.
Cool. And before we jump to that, Dmitry is saying, like, there are some concerns about the mix of like components which use imports and then modules, like all those things like coming together being like a bit messy.
Yeah, that's actually a good bit of what we're working on today. is the compiler needs to really help you understand if you're putting these things in the correct place or not. So
cool.
if
So that's
if you go and say, like, I want to import calendar component here, right? And if this is not a standalone component, the compiler should be able to tell you a better error message than just, hey, this is not an ng module, right? Ideally, it will tell you, oh, you're trying to import this thing. I see that it's a component. I see that it's not standalone. And I see that there's this ng module beside it that exports it. So you should probably be importing the ng module instead. Conversely, if you try to declare a component like app component here, right? We make app component standalone. Then the compiler should say, like, hey, you can't have this thing that's in an ng module and also standalone. So with error messages, we should really be able to give you like good hints that you're using these things in ways in which they weren't intended. So you don't have to kind of keep track of what's standalone and what's not.
And then the other question also from Dmitry, he's asking, like, there is the standalone true flag, which I kind of see, like, when you teach Angular, I think like having standalone components like is easier to teach just because you don't have to worry about another thing, which is like a module. But then you always have to have the standalone true, which is kind of confusing for teaching. So did you consider like kind of inferring it if it has a depth fields, for example, it's a standalone, or can there be a standalone component without a depth imports field?
We generally prefer in Angular to have things be explicit. And there's a few reasons why you would want to have this flag here. One is that in the TypeScript typings of at component, we can actually verify that if you put imports in here, that standalone is true. And so at the TypeScript level, you actually get an error if you try to add the depths to a component that's not standalone, or vice versa. Which I think is a valuable reason to have kind of the flag be there. Standalone is also a thing for directives, right? So if I have a directive that I'm writing, I can make this class like my directive, right? You can make directive standalone even though they don't have dependencies. They don't have depths. And again, this is because you are promising that I am not depending on the DI configuration providers and stuff in an ng module. I don't, you don't need to import an ng module and create an injector and all of that to use this directive.
Cool. Okay, so basically the idea is like if people forget it, we just let them know with a TypeScript error, and then. But by the way, do you have like control? Like, would you be able to take that specific TypeScript error and be like more specific? Like, oh, this is looks like it's a standalone component, and we want this property there. Oh, you can
absolutely
do that. Cool.
Yeah, that's. I view this as kind of one of the main jobs of the compiler, is to give you really good contextual error messages when you get things wrong. And it should go almost as far as like being able to suggest what you should have done if the compiler can know that.
Cool.
And we have a lot of infrastructure in the compiler that we'll get into on making sure we can produce those kinds of error messages.
Cool. Exciting.
Yeah. So what I was hoping to accomplish today is to add an error related to unused dependencies.
Okay.
So let's say we make this application component standalone, right? And so I say here, I want to, I'm going to make this standalone, and I'm going to import, let's use our calendar component, right? And then I go about writing the application. I use the calendar. I use some other stuff here. So I check that in. And then someone comes along and says, you know what, like this application doesn't need to display the calendar right away. So they make a PR to remove that usage of the component from the template.
And I forgot the import.
And so this is now an unused import, right? And one of the problems with this is because you're importing calendar component, right? We can't tree shake away the component or the services or any of the dependencies that it imported,
Mhm.
because they may actually be bringing providers into the system. So like this import is not as tree shakeable as
Right.
it was in an ng module, because this has real meaning,
Mhm.
right? This means that if and the application has to like include providers from this thing.
Mhm.
And so we want this to be a hard error.
Okay.
The compiler should tell you, hey, you shouldn't import something that you are not actively using.
Mhm.
And so that's the error that I'd like to build today.
Cool. Let's do that.
Yeah. So, you may have a list of things here. We may have so some of the challenges, I guess, associated with doing this, right?
Mhm.
First of all, in Angular, it's possible to nest these things,
Oh, yes.
right?
Mhm.
So this is an interesting case. Like, what do you do here?
Mhm.
Do we send into this array and like try to give you warnings about these things? Because this could be used in many different components.
Mhm.
So there's some level of like, we have to decide what the right experience is in cases like this. There's also the case where I could be using like a shared module in here, right?
Mhm.
And if I'm using the shared module, this could have 5 different components that it's exporting.
Yep.
And if I'm only using 3 of them, like what do we do in that particular case?
Mhm.
Calendar component could be coming from multiple places in here, right? I could also have like calendar module that I import,
Mhm.
which takes the standalone component and re-exports it. That's a thing that a lot of libraries, I think, will do as they migrate to standalone, because people today are importing through the ng module.
Mhm.
So if I had this calendar component, it is not standalone today, right? You would say this is
Mhm.
declaring the calendar component and exporting it.
Okay.
And what this library author might do is say, oh, I want to start using standalone components here.
Mhm.
So I can no longer declare this thing.
Okay.
Instead, I'm going to import it, export it. And so
Okay.
anyone who's using the ng module today still continues to be able to do it,
Mhm.
but I've made the component standalone.
Yeah. Okay. But you
And
still you can use it both in the module for backwards compatibility and as a component.
exactly.
Yeah.
And I believe we'll be doing this with all of the directives that are kind of part of Angular Common.
Mhm.
So ngIf, ng4, etc. You will be able to say like, I want to import ngIf into my standalone component here.
Mhm.
Or you'll be able to say, I want to use common module.
Mhm. Oh, I
So
see. Okay.
common module works for backwards compatibility, but all of these things become standalone and can be used independently.
Mhm.
So that's another interesting question, right? Like, say I'm importing ngIf and common module.
Mhm.
This is unnecessary, right?
Right.
I may only be using ngIf and I've
Mhm.
imported it directly. Or if I haven't imported it, I
Mhm.
could, right? I don't need all of common module. I just need ngIf.
Mhm. Oh, but then you want to say, oh, there is an alternative. You can actually just import ngIf.
Yeah.
Mhm.
So some of these might be suggestions that the compiler makes, right? Like, hey, you don't need this whole module.
Mhm.
You just need 2 or 3 things from it. That could be done as a warning, not a hard error, because we want to be backwards compatible. But if you're not using anything from this module, right, then we should be able to tell you, hey, check this out. So that is generally the plan.
Cool.
Before we dive in, any questions?
All right, chat. Do you have any questions? Just completely random question. I'm curious, like, what was your favorite part of Angular which you worked on, which was like the most interesting / challenging?
That's interesting. So we did over the past few years, right? We've been working on this large scale project we called Ivy, which was kind of, it's supposed to be an internal rewrite of how the rendering engine worked, but ended up having a lot of externally visible effects because we were able to have new APIs in certain cases, and we completely rewrote the compiler. And so I was kind of leading the effort to completely rewrite the compiler. And when Mieszko told me I would be doing this, I had never worked on a compiler before.
Okay.
And he basically handed the project to me and said, like, hey, run with this. Like, we need it to work at some point, see if you could figure it out. And that was an amazingly rewarding experience. I've worked on the Angular compiler for about 2.5, almost 3 years now, and took it from literally the like, first few lines of code to where it is today, with the help of some amazing contributors along the way. But yeah, that's, I think I came home from work that day when Mieszko gave me that assignment and went on Amazon and ordered like 4 different compiler books, because I had no idea what I was doing. It also doesn't help that the TypeScript APIs for the compiler are not super documented.
Oh yeah.
So there's a lot of kind of reading TypeScript code and stepping through it to figure that out. But I like challenges like that with really nebulous goals that you have to achieve.
Yeah, that's cool. That was a huge project.
Yeah.
Yep. Daniel asked if there are any like Easter eggs in the Angular source code. I mean,
yes, there are, because I put one there.
Okay.
Are you familiar with Igor's kind of catchphrase almost that he's used at a lot of Angular conferences, which is, it's just Angular?
Okay. Oh, it's like, it's just JavaScript for React.
Yeah, well, in the early days of Angular, right, there was some confusion between AngularJS and the 2.0 version, which
yes, got it.
It was not in JS, it was in TypeScript and Dart at the
time.
And people were calling it Angular 2, and then Angular 4 came out, and people were talking about Angular 4, and Igor wanted everyone to stop focusing on the version number, because we had switched to semantic versioning, and we were going to do a new major version every 6 months. And so it didn't make sense to like list on your resume, right, that you're an expert in Angular 6, because that was going to be obsolete by the time you were applying for jobs. And so he put into his keynotes and stuff, like, it's just Angular. And so as a little kind of tribute to Igor in the code, it's just Angular. So the compiler has to build every Angular package out there, and it also builds Angular core. And it has to treat Angular core a little bit specially.
Okay.
Because in every other package, when the compiler needs to import something from the runtime, it imports it from Angular core. But when it's building Angular core, it can't do that. That's self-referential. So the compiler needs a way to know that it's building Angular core so it can treat it specially. And the way it knows that it's Angular core is it looks for this particular constant.
That's pretty cool.
Yeah.
Nice. Okay, somebody says it should have been called Angular TS as opposed to JS.
Yeah, maybe. We actually were also building, we were taking the TypeScript code and transpiling it to Dart at the time. So
is that still a thing?
It's not still a thing. Angular Dart is still a thing, but it forked away from the Angular code base a long, long time ago.
And at which point did you join the team? I know you've been there for a while.
Yeah, I joined kind of right before we went, I guess, right before the first alpha versions of Angular. Kind of right around the time we had decided to adopt TypeScript. One of the first things I was doing was converting JavaScript files in the code base.
Oh, fun.
Yeah.
Did you know what you were getting into?
No, I had no idea. It was a lot of fun. It's been an amazing experience on this team. most people at Google tend to work on a project for 2 or 3 years. I've been on Angular for almost 7 now, and still love every single day.
But were you like specifically going for the Angular team, or did you like pass Google interviews and like, oh, that sounds like an interesting option?
Before Angular, I worked on a project called Green Tea, which the name is just kind of a code name, but it was Angular, or it was Google's sales management system. It's like CRM, written in Angular Dart. And so I worked on that, working on kind of the RPC layer for how the client communicates with our server APIs, built an API client in Dart, and was kind of starting to tackle some of these problems around how do you do applications that like process data reactively, how do you cache things correctly, how do you synchronize between client and server. And Brad, who was running the Angular team at the time, and was also running Green Tea, kind of talked to me and said, hey, do you want to solve the same problems, but on a bigger scale? Yeah. And so I joined Angular, and for the first couple of years worked on kind of data client and progressive web apps and things like that. And then jumped over to kind of working on the core framework stuff.
Cool. All right. I think there's another question. How many hours per day do you actually write code?
Oh gosh, these days not many. So I recently took over as what we call the technical lead, or TL, of the Angular framework team. And so I'm spending much more of my time kind of in meetings and writing design docs and writing process docs and like reviewing other people's code, and generally kind of helping the team to be productive as much as possible. So it's actually really nice when I get a like chunk of an afternoon to just sit down and work on code myself.
Oh yeah,
yeah, definitely. So I think I would say I average in a week about 30% of the time writing code.
Oh, it's not that bad.
Yeah,
actually.
Not terrible. It's like at some point it becomes more about what code you write and not much of it. So I find that I'm spending more of my time figuring out what the right thing to do is. And then like with standalone components, there's so much discussion that goes into making a huge change to the mental model of the framework like that. And then when you actually sit down and do it, the actual change you're making is not that large.
Cool. And NanoCrate asked if you actually were involved in the decision to like adopt RxJS and kind of make it a kind of part of Angular, and like what you genuinely think about it.
I was not. RX was kind of we were talking with forgetting his name, but there's a gentleman from Netflix who was kind of involved. Ben Lesh was one of them.
Oh, another one. I don't know Ben Lesh.
Yeah. I'll remember his name eventually, but yeah, we were talking with a couple people from Netflix about RxJS, and they were showing us kind of how cool the observable pattern was, and how it was beneficial for art applications. No, it's not Haseem. I can look it up. Okay. I want to say his name was Jafar.
Okay. Okay. I mean, if just when you remember it, just shout it out.
Jafar Hussain was his name.
Okay.
He gave a couple talks at Angular conferences.
Cool. And so he was Jafar Hussain. Yeah. He was like a proponent of RxJS.
Yeah. So he and Rob Wormald, actually, who was kind of in the Angular consulting space at the time and ended up joining the team, was also hugely a proponent of the reactive style, and kind of contributed a lot of those bits to Angular. I think Angular today is in a kind of a poor state with RxJS, where it's sort of half supported across the framework. And so certain APIs are done in a very reactive style, and certain APIs are done in a style that kind of really doesn't play well with Rx. Inputs are one of those things where like everyone wants to get their inputs as a stream, as an observable, and that would really make sense. But not everyone wants to use RxJS in that way. And so we've been kind of in this space, in this place where we've been pulled in two directions for a very long time. And we're starting to think about how we can kind of evolve to support the RxJS use case without necessarily making it the center of the framework. So that people who want to use Angular entirely without Rx are able to do that. But people who want to kind of lean all in on the reactive style can build the kinds of experiences that they want on top of Angular. So if you could get reactive inputs, RxJS observable inputs, as an option, right, as an add-on to the framework, I think that would really be the best case scenario. But that's very hard to do. So it's going to take lots and lots of thinking to know what to write there.
Okay. Then says Jafar Hussein was working on trying proposal to add observables in the browsers, and that didn't work out as far as I know, right?
Yeah.
It's very interesting. Observables, decorators, basically very hard to add things in the browser.
Yeah, the TC39 just approved the decorator spec, which is one of the reasons why we're thinking about maybe redoing the DI APIs a little bit too.
Oh, they did? I thought it was kind of on the shelf for a while.
Yeah, no, they're moving forward with it. And it's slightly different from the current spec. And the difference is around parameter decorators. So parameter decorators are not a part of the in-browser spec.
Oh, like inputs and
outputs? Like the way we use, so those are field and method decorators. Those are fine.
Okay.
But it's the parameters
inject.
To function, like add inject, add optional, etc., might not didn't make it into the spec. So we will probably long-term align with that. For now, like add inject is not going anywhere. TypeScript is not going to change how they do decorators. So
cool.
Yeah.
Okay, this is not a question, but Dan says my favorite part about Angular is probably how template type checking was done with Ivy. That's actually pretty smart.
Yeah.
Right?
Yeah, that was a lot of fun to figure out how to build. And I wrote a blog post recently for the Angular blog on how the compiler works, with a section on kind of how the template type checking engine works. And that's, that was pretty crazy to be able to do things like that on top of TypeScript.
Yeah, I'm looking this up. I think I found it's like blog Angular IO, February 9th, right? I'm just gonna post it in the chat. Yeah. Cool.
Yeah.
All right.
So let's see if we can get a basic error working. So let's go to, I think I have standalone spec here. We're going to be good test-driven developers and start with a test. So the compiler has a testing framework. And I've already written some tests here, as you can see, for standalone things. So this test verifies that when you import something which is not standalone directly into ng module imports, you get an error telling you exactly what you did wrong. So I will, for the sake of saving typing, copy this test.
Nice.
And we'll just put it out here for now.
So this is like Jasmine?
Yeah, this is Jasmine. The compiler has this thing called a test environment. It basically implements an entirely in-memory file system that allows us to take essentially code as a string and feed it to the compiler and understand semantically what output we're getting.
Oh, wow.
And so here, let's say we make this, we'll use this directive, we'll make it a standalone directive. And we'll import it into a component instead. So we'll call this selector test component, be a standalone component, import this directive, but then it has a template which is not going to use the directive, right? not use the directive. So we're importing this thing. We're not using it. We want the compiler to tell us about this. This should be an error. And so the way this...
So you have a standalone component and you import the directive, but you do not use it. So you want to say like, hey, why are you not using the directive?
Yeah, I want the compiler to underline this for me and tell me, you didn't use this in your template. You don't need to include it in your imports, right? And so looking at the previous test, you can see here that we have this option to, there are a few methods on the test environment called drive. One of them is drive diagnostics.
Okay.
So this basically says, run the compiler and give me back all the errors that you found in the code.
Okay. And then you expect one error to be there, and the message would say this and that.
And we also expect something about where the error was located. So we take the diagnostic that we got. We expect that diagnostic to be something on something called a TypeScript identifier, just a name in the source code. And then we walk up and kind of get the larger expression around it, which we expect to be this imports line here.
Okay.
So the thing we really care about, right, is one, did we get the right error message? And two, was the error message contextualized? Was it in the right place?
Okay.
So that's what we're going to do here.
Cool.
So I'll just say for now, like, is not used, right? And we expect kind of the same location of the error. So it should be on this tester here. So we expect to see like this expression.
Yep.
So this should be theoretically complete. And we can try to run it.
Right. It's gonna fail, right?
I'm going to do one other thing, I think, which is, I'll just set this up here. So in the compiler, we also have an abstraction over the file system that you're using. We have this in-memory program that we're running. And that allows us to do things like test that the compiler works with Windows paths, even if you're like me and developing on a Mac.
And then what does native do?
Native is a debugging tool to just say, I only want to run using the system file system.
Okay.
Otherwise, it would run this test once for all of the, like, for Windows files, for case sensitive Mac, for non-case sensitive Mac.
Oh, that's very cool. That's how you get less Windows errors. Right?
Yeah. Until we built this, actually, we were breaking Windows on a regular basis, and then people would complain to us, and we'd have to go like, okay, why, why does this not work on Windows? And so we ended up building this whole abstraction layer for dealing with paths. And after that, we haven't broken Windows in like ever.
That's cool.
Yeah.
So it does like Mac, Windows, Linux?
Yeah. I think we have native, OS X, Unix, and Windows. Yeah.
Makes sense.
So now we're actually running the tests. And it fails as we expect, and I'm guessing it fails because we did not get any diagnostics.
Yep.
Yeah. So the compiler was able to successfully compile this code, even though we don't want it to.
Cool.
So
let's create those diagnostics.
Let's create those diagnostics. Exactly.
I'm pretty excited because like most of the things I use, I kind of understand how they work inside, but this one, like, I have no idea. Like I know that compiler compiles something, and then.
So let's. I don't know why Node modules is open here. So the Angular compiler is split into two packages: compiler and compiler CLI. The main distinction is that compiler CLI is the TypeScript only version. And compiler is kind of the general purpose, things which don't depend on TypeScript. So this actually does the compilation
Does what? Sorry.
So compiler CLI depends on compiler.
Mm-hmm.
And compiler actually implements all the compilation, and it's used both for JIT and AOT.
Mm-hmm.
And then compiler CLI is the AOT driver.
Okay.
And the compiler is split into a bunch of packages internally, this is all of them here. So we have annotations. These are the decorators that are on classes. There's the core. There's cycle analysis for figuring out when there's import cycles. Diagnostics defines all the error codes and utilities for working with errors. We have entry point analysis. We have our file system abstraction. We have the import graph, which we'll probably be working a fair bit in. We have incremental compilation, code indexing. This is related to like doing Google's like code index of the whole code base. We have logging, we have metadata, partial evaluation, which is a really interesting operation that we'll probably talk a little bit about.
Oh, that's okay.
Performance, program drivers, like how incremental compilation works again. We have reflection code, working with resources like template files. Scope is a package that we really care about today.
Okay.
This is the bit that understands ng modules. We have shim generation, we have source maps, and then we have the actual like transform and translator, which are compilation code. And then the template type checker.
Okay.
So this is a big project, right? The compiler is actually many thousands of lines of code. So you can read the blog post that I wrote, which gives a kind of more in-depth overview of how compilation works. But I'll give you the kind of 3-minute version here.
Okay.
We basically have, for our purposes, we have 2 phases of operations that we do. The first is called the analysis phase. And you can imagine someone hands you like a whole application, right? The first thing the compiler does with this application is it looks at each of the classes that have Angular decorators on them.
Okay.
All of the components, all of the add ng modules. And when it looks at a component, it might not have seen the module yet, right? It's going through the code kind of in the order that you gave it. And so it's only able to understand this thing kind of in isolation, right? We can figure out what the template is. It's right there in the at component. We can figure out what the selector is, but we don't know what the things in the template are because we don't know what the module might be, right? We may not have found that yet. Later on, when we're going through the rest of the code, right, we may find the ng module and see that it points at the component. Or we might find the ng module first and see, well, this declares app component, but I don't know what app component is.
So we know all the parts, but we don't know how they're connected yet.
Yeah. So the analysis operation basically says, let's just try to understand each class in isolation. And we build up a database of all of the components, all of the modules, all the directives. And then we go through everything a second time. And in that second time, we have the benefit of having seen and analyzed all of the pieces on their own. And that's when we can start to make connections, right? Okay. The second phase we call resolve. And the resolve phase's job is to understand the component in context of the whole program. And so we'll probably be making a couple changes in both of those operations. Okay. And so we have this abstraction called a decorator handler. And each of the decorators that you might have on a Angular type gets its own decorator handler implementation. And this thing literally has, if I condense all this stuff, the analysis phase, and somewhere here, not necessarily in order, the resolve phase. So the other stuff, here's template type checking, right? Very interesting code, but we're not going to be doing too much in there today.
Can you close the left part?
Yeah, sure.
Yep. Thank you. Maybe make a little bit larger.
Yeah. And so one of the things that happens during resolve is we figure out what is used in the template and what's not used. So we have this operation here. Let me see what's going on. I haven't worked in this code in a while.
Okay. So I can see on like 549 we create like an empty diagnostics array, and then we are gonna fill it as we go.
Yeah. We have this operation called scope template. And what scope template does is figure out what are the things that could possibly be used in this template. And so if we go into this operation, we see we check whether this component was registered with an ng module. This calls into an API called the component scope reader. So previously in the analysis phase, right, we went through all of the ng modules and we built up a mapping of which ng modules declared which components. So now we're querying that map and saying, hey, does the ng module world know anything about this component? And if the component was marked as standalone, right, if the analysis data that we got from the component said, I'm a standalone component, and we found an ng module for it, there's a problem.
Okay.
Right. So here's where we kind of crash out.
Standalone declared in ng.
Yeah.
Okay. So scope, it's not a Boolean, but it only exists. It will be null if the module doesn't exist, and otherwise it will have some module information.
Yeah.
Okay. And declared.
We also have this concept of poisoning.
Okay.
So a scope can be poisoned, and poison just means there were some errors involved in its declaration, and we pay attention to that because we don't want to like show you a million errors for a template where your real problem was that like something was wrong in your ng module and we couldn't understand it.
Oh, so if it's poisoned, we just don't do anything, right?
Yeah. So if there's an error in the ng module, right, then we say the scope is poisoned, and the component won't give you a bunch of template errors from a poisoned scope.
Got it. And the same thing with the previous one, we do not throw any errors because it will be thrown on the module side.
Yeah, the ng. If you looked in the ng module analyzer, it would make that an error.
Cool.
So then we have, this is the big, are you a standalone component or are you an ng module component? So if you're an ng module component, then we look to the result we got for the scope was an ng module scope. You can module scope. And that tells us what are the directives and pipes that could be used in this component.
Okay.
If it's a standalone component, we're going to try to understand the imports. And so if you don't have any imports, obviously, then you don't have any directives or pipes. But if you do have imports, then we go through all of the resolved imports and try to understand, is this a directive? Is this a pipe? We might make some diagnostics if you got this wrong, right? So if you're importing something that's not a standalone component, then we make this not standalone diagnostic. If you're importing something that's, where's a good, okay, it's the error somewhere else. Let's actually look at this function, make not standalone diagnostic, because this is going to be interesting. So diagnostics are somewhat complicated to construct because you have to have pointers into the right code and get the wording right and stuff. But one of the things you see here is we get this reference. And reference is a compiler abstraction that basically says I'm naming a class, right? So I'm pointing to a class that someone wrote in this case, because it's a reference to a class declaration. But the reference has context.
Okay.
So it understands, references know how they were derived. So the reference is kind of tied to like where the Angular compiler saw you trying to name that class. And so this reference, for example, will understand that it came out of the imports array. that was in the component.
Okay.
We also have this raw expression, which is the raw expression of the imports array.
And that's something we use in the errors to...
Yeah. And so one of the things you'll see here is we call this operation called get diagnostic node. And we pass in the reference and the raw expression. And this is just kind of wrapping some logic to deal with nulls and stuff. But we end up calling this method on reference get origin for diagnostics.
Okay.
And this is the part that basically says in this larger expression, which is the imports expression, and try to find which one of the imports, if we have imports was A, B, C, D, right?
Okay.
And we have a reference to C. Basically look in this expression and try to find what caused us to derive C. And so that will allow us to kind of underline, highlight exactly the part of the expression that caused the problem. So we make the diagnostic basically at the right place. So we could have so we're going through all the imports. We see if we found any directive information for the import. If we did, it's a standalone directive, right? Or it's a directive. And eventually, regardless of what happened here, we kind of continue on in the loop. If it's not a directive, then it might be a pipe.
Okay.
If it's not a pipe, then it might be an ng module that you're importing.
Can a pipe be standalone?
Yeah, pipes can be standalone. And pipes are not really fully implemented here yet. This is code that's kind of still under construction. But if it's not a directive and it's not a pipe, it better be an ng module, right? So if it's an ng module, then we get its metadata, and we particularly care about the components and directives that it's exporting. So we go through the exported directives and the exported pipes and kind of bring them all into the scope of the standalone template.
Wait, can there be like component? Like can be directive, pipe, ng module? Why not the component?
Directives or components are a special case of directive in the compiler.
Okay, so it handles
in
components.
Angular in general. Yeah. We under the hood, they're kind of the same thing.
So we're gonna plug in somewhere there and say like we have this component, is that used?
Yeah. So this is how we turn the imports into a set of directives and pipes.
Got it.
And so that's how we kind of arrive at this scope. And the next thing we do is an operation called directive matching.
Okay, that's a very long comment.
Yeah, the compiler has a lot of comments. I'm a particular believer in recording kind of the why of when things happen in comments. So what this comment basically says is we need to take this set of directives that we have and figure out which ones of them are actually used in the template. And we do that with this thing called a selector matcher.
Okay.
So we're going to add the selectors of every directive, every component, every pipe. Pipes have names, not selectors. And then the compiler has operations that allow us to figure out which directives are used. So eventually we have this get used directives that we end up calling to figure out which directives are used, and we have get used pipes. Same. And so at this point, right, we now have use directives and use pipes. Also know all the directives, all the pipes. So theoretically here we can do our check.
Okay.
right? So let's see if we can figure out a way to do that. The first thing that I notice is if we look at the use directives, right, this is an array. And it's not a set, and so we can't query directly, like, does this thing contain a particular directive? So there are two ways I could think of doing this, right? One is the additive way, where we go through all of the directives and we say, if this is not used, then we add it to the list of things that's not used. The other is subtractive, right, where we put them all in a set and then remove the ones that are used. And it looks like we're kind of set up better to do the subtractive version.
Okay, so I'm gonna turn it in a set.
Yeah, so where was our, we had scope dot directives, was a array of directive metadata. So all directives, or let's say unused directives, right? This new set, we're going to map directive to its the actual TypeScript node of the directive. We do that because regardless of how that directive was imported, whether it came through an ng module, etc., the node is always the same, right? There's one class declaration that corresponds to that directive.
Okay.
And so now what we can do is, in all of the use directives, we can remove are used. So now unused directives have actually unused, right? So we could validate here, basically, if unused directives size, I think, greater than 0, new error, right? There are unused directives. So now we can run our tests, and we should crash at that location, I would think. If not, then we have a problem.
Just
blah, 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 blah.
Okay,
blah.
it's not used.
Error, there are unused directives. We crashed in resolve. Yay, right?
Nice.
We've uncovered something. Now we have to go about turning this into an error.
Okay, let's make it a nice error.
Yeah, let's make a nice error. What are the components of a nice error, right? We need the error message. We need the error location. And we need the error code.
All right.
So location is going to be the hardest, and I think it's going to require us to go back and kind of recompute how we do this.
Okay.
Because we're going to need this reference, right?
So should we just put it in a set?
Yeah, we'll probably end up putting it in a hash map.
Okay.
Or a map would be my my inclination, but we'll go through this kind of more methodically. So error code. All Angular errors have a 4-digit error code from the compiler. So we will go to reserve one.
Nice.
So component import not standalone, component unknown import. So we want to add a new error code to the system that says, raised when a component import is not used in the template. Component unused import 2013.
All right.
More than the previous. Perfect. We have our error code. So our diagnostic here, we're going to call a function called make diagnostic. First thing it's going to ask us for is the error code that we just created. So component unused.
2013.
We now need a node. So where are we going to put this? Just pass null. No. And we need our error message. Okay. This isn't used in the template. We can work on that later. We also have the option, right, of showing additional information. And that's useful in TypeScript. You see this when you have kind of the red underlined error. Underneath it, indented, you have a pointer to something else in the code. It's like, maybe you meant to call this function. And it has like a teal, blue, light blue, green underline. So that's kind of related information. We probably don't need to use that for this particular error.
Okay.
And then we'll push our diagnostic onto the list and proceed with our lives, right? So we have our error code. Okay. We have our error message.
Yep.
How the heck do we locate this error?
Time for the map.
Yeah. So what we want to do is show the error. So here's where things get complicated.
Okay.
We have imports, right? And so one scenario is we have foo component here, or let's actually, we had our directive. Our directive is not used. And here it's very clear, right? We should be pointing basically big red squiggly lines at this guy. You're not using him. We also could have had imports from a shared module. Where shared module happens to also export dir. Right? This case should not be an error. Right? Because you may actually be using things from this module. So what we really care about is not necessarily whether specific directives and pipes are used.
But
what
the
we care
standalone
about
ones
are the actual entries of imports, right? Regardless of what you put in imports, A, B, C, D, E, we care about, is there anything in here that is not used? Is there anything in here that is not used?
But what if you have a shared module which has two directives and none of them are used?
Yeah, right. So if shared module here, if you say imports shared module and nothing is used, then we do want to give you an error on shared module itself.
But yeah, we currently don't have a test for that, so we can just figure out the directives first.
Right.
But would it be safe to check is standalone flag on directive?
So that's another interesting point here, right? Is like we probably also need to make sure that we're a standalone component when we do this.
Right.
So good point. We only want to be giving this error for standalone things. So what we actually kind of want to do is go through this imports array in a different manner than we already had, right? Before we've collected this all directives thing. So we know that the array of every directive, but we basically want to go through individually each of the entries and imports and figure out, is this exact thing used?
Yep.
Or, if it's a module, or is anything from the module used? If it's a standalone directive, is the standalone directive used? It could also be a constant, right? So I could have const directives is ABC. And I could add directives here. Generally in the compiler, we understand this, but in our errors, we don't break it down for you.
Mhm.
So we wouldn't say like, oh, this is unused here, and try to highlight this node because it's a member of this.
Mhm.
We would
Mhm.
treat this as a chunk of stuff.
Mhm. Is it like for performance or just because you cannot handle any keys?
Because yeah, you can get kind of crazy complex with stuff like this, right? This could be from a function call. It could be, you know, um, so I could have a function call around directives that like does some transformation of it. So the compiler really can't, in the general case, understand like that this thing is referencing a constant,
But is
and
it
be able to do good errors there.
is it smart enough to figure out what will eventually go into imports?
Yes, it's
Oh.
smart enough to resolve. So there was an operation the compiler does called partial evaluation, which is really interesting, and we're going to have to get a little bit into it to start doing this. But the
That sounds
compiler
cool.
can partially evaluate this constant and understand what the final value will be.
Wow. Okay.
It
So
just
it's
doesn't
not static;
necessarily.
it actually runs
Yeah.
part of the code.
Yeah.
That's very cool.
So to perform the operation this way, we have to start looking at where did we get this imports data in the first place, right? And that happens in the analysis phase.
Okay.
So in analysis, we are kind of reading each field on the component decorator and understanding what that field is trying to tell us. So for example, here's where we read your view encapsulation flag. This is where we read your change detection strategy, right? Maybe your on push component, providers and view providers. And here is imports. Right? Here's where if you say your imports, but you didn't say your standalone, we yell at you. Right?
Nice.
Here's where we figure out your actual imports. And notice what we do is we look at your component metadata and say, oh, here's your imports. And we ask our partial evaluator to evaluate it. So here's an expression. What does the compiler think the value is? And we get back is this thing called a resolved value.
Okay.
And this resolved value is why is this taking me to dynamic value? That's so weird.
That's a different one.
It's just the language service being screwy. I think it's because it's the first or the last item in this list. A resolved value is like what value does the compiler think this expression has? Could be a number, a boolean, a string, null or undefined, be a reference to a class. It can be an enum value, a value from an enum. It can be an array of resolved values. Right? It can be a map of resolved values, like an object. It can be an imported thing. It can be some function that we know exactly what it means. And the last item in the list is the compiler can say, got no clue. Right? If you try to resolve, if you say imports, right? Like, what's a good example here of like, oh, I want to like resolve a promise, right? I want to do some dynamic thing.
Oh yeah, then you have an idea, right?
Then the compiler's like, I give up. Like I can't. There's no way for me to know at build time what value that's actually going to be.
But out of all those things, only some can be in imports, but some can be found in other places, right?
Yeah, exactly.
Like imports, you basically expect those
static
components
imports
modules
we can find, right? So going back to our understanding of imports, we've asked the evaluator to evaluate this expression as a single array. And what that means is what we get back is the resolved value array of everything that was in that imports expression. but we've kind of lost the plot a little bit there about what the like individual members were.
Mm-hmm. You mean type-wise?
It's a good example of this. Maybe not. Maybe we're okay here. Yeah. Oh, that's okay. This is the problem.
Okay.
So what we get back here is an array
Mm-hmm.
where the values in like, so if we had imports here, said A, B, C,
Mm-hmm.
what we'll get back is a reference to A, a reference to B, a reference to C.
Mm-hmm. Okay.
Maybe, right?
Mm-hmm.
If the user wrote something like this,
Mm-hmm.
what we'll get back here is
Right.
actually
Array of references.
reference to D, reference to E, right?
Mm-hmm.
So for every value in this array, the compiler kind of resolved it to what it actually means, as far as we know. And this guy resolved to another array that had two things in it, which we understood to be classes. So that's what we get from imports. And then we go and flatten it.
Mm-hmm.
And the result after flattening,
well, basically just one level array.
Yeah, one level array.
Mm-hmm.
And that's where we're kind of losing the information about what the actual entries in the original array were. Right?
Yes.
So I think what we need to do is keep track of not just the flattened imports, but the actual final array.
Yeah, but technically, like, I don't really need to flatten it. You mostly do it just to simplify handling, or is there?
We flatten it because we're only interested in the set of imports, right? Not necessarily how the user decided to structure them.
But once we have a reference, wouldn't it have like a link to the node, which would be potentially like outside or wherever it was declared?
Yeah, reference has a link to the actual class, right?
Then would we have to worry about where it's coming from?
No.
Okay.
Which is why we flatten it, because we don't care about that like nested array anymore. Right? We just want to treat this as some set of imports.
Okay. And in our case, do we need to care about that now?
In our case, we want to care about it because we actually want to step through the original the user wrote and understand what are they.
Okay.
Right? We want to ask, is anything in this directive thing used? And so a good way of doing that, let's see.
Okay.
I think we want to just keep track of, we have the resolved imports. Let's say we keep track of the unflattened, right? It's going to be this, I think.
But it also can be an array of things, right?
This guy is going to return the unflattened imports. Oh yeah, it can be an array of things.
Right.
So this is actually resolved value array.
But do we need to pass it through? Can we just reuse the same thing? Do we need to pass it to like this specific function? Oh, because it does something?
Yeah, this function has a particular responsibility, which comes from validate.
Oh, so we're missing validate. Okay.
And validate's job is to say, like, are the values in this array actually what we expect them to be, right? So make sure that you didn't do imports 3, right? this is not a reference. This is it's like just a number. And so we're checking essentially semantically, like, is it an array? And as we flatten it, are you actually pointing at class declarations? And so, yeah.
Okay, that would be interesting.
Yes. I'm trying to think of the right way to do this. So we're going to find a reference. We need... No, this might be the wrong approach.
Okay.
Because when we do this resolve operation, one of the things we actually do, like if you had A/B directives here, right? We convert this to an array, but that means we actually lose this node.
Yes.
And this is the node that we care about. Okay, so we shouldn't do this.
Yeah. Can we just look at result of validation and form the unflattened array based on that?
I think what we want to do is not have this unflattened thing produced in analysis.
Okay.
But back to... We essentially want to do the first part of resolve manually.
Okay.
So in the case where we know we need to make these errors, right? What we want to do is, let's see, we have analysis imports. Have this raw expression. Okay. This is the imports array as the user wrote it, right? In TypeScript code.
Okay.
So we can basically expect that it's going to be an array literal. And this allows us to iterate over the actual nodes in that array literal.
Okay.
Elements. So the things in each each import expression that the user wrote. So if they wrote imports A/B directives, right? Then we're actually iterating over these individual members, which is exactly what we want.
Okay.
Because this is the node that we want to produce the diagnostic on if they got things wrong, right? So the question we want to ask here is anything in node used? That's our error. Okay. It might be a module, it might be an array, whatever, right? So what are the things in node?
Okay.
First thing we probably have to do there is go from node itself to partial evaluation of it, right? Convert from this expression to a, like, what does this actually mean? So this is like the partial imports from node.
Okay.
Going to ask our partial evaluator again to evaluate this expression. In this case, we're just evaluating a chunk of the imports, right? One item from the imports, but not all of the imports. And from here, we can call our validate and flatten component imports using imports from node and using.
But can we do it it's not necessarily an array anymore, and I think this thing expects an array.
I think you're right. So I think we probably need to pass in an array.
Okay.
That's a good point. Just to kind of trick this function a little bit. And we're mainly using this for the flattening, right? Because they've already been validated. So let's say, get out here the imports and diagnostics. We're going to rename node diagnostics from node, right? I always get this order wrong. Right.
Why doesn't it just return like imports and diagnostics?
It returns imports and diagnostics, but we want to rename this one.
Oh, got it. Okay.
The diagnostics variable.
Oh, okay.
So I'm just going to basically say, if there are any diagnostics, then we just want to skip it. Right. Basically, if this didn't validate correctly, then we have no hope of checking whether it's used or not. So here we'll call this imports from node. There's imports is like imports flattened, right? So now we basically ask the question, what directives pipes are in imports flattened? Once we get that, then we can check whether any of those are used and know whether or not to produce the error. So this is the hard part, right?
Yep.
So I think we're going to try to lean on code that we already have, which was way up here. We had the scope template function that we were looking through. And this like took in a bunch of information, the imports, and had all these other classes and stuff to try to figure out what the scope meant. And it had this if branch.
Okay.
It was actually going from the imports to the set of directives and pipes. So we're going to refactor this code a little bit to allow us to use this logic for a subset of the imports.
Okay.
So we'll call this function, what was this called? Scope template. Scope standalone imports.
Okay.
And we want this to return basically the same thing. Scope template result. We won't return null because we know certain things that the other function didn't.
Okay.
And we probably want similar arguments. So we need basically all of these things. Except we don't want to take the analysis. Just want to take the imports as a reference class declaration array, raw imports expression as a TypeScript expression. So we basically want to clip this code out. All of this stuff and replace this with earn scope standalone imports. So scope reader.
Have to pass all those things.
Yep. Dependency injection, beautiful thing. We don't have it in the compiler.
Is it a performance reason or just didn't happen?
Well, our dependency injection in Angular uses the compiler. So we can't use it in the compiler. You would have to compile it with the compiler.
That makes sense.
Yeah. So actually this, we'll just, for the sake of logic, say this can be null. So instead of passing the analysis, which is all of the imports, we basically say if the imports are null, go through imports This is just the imports that we care about. It's our raw imports expression. We're just changing this code to be a little bit more general and to operate on exactly operate on a subset of imports potentially. And so here we actually
pass the imports.
Yeah.
It's analysis imports, I think, then.
Yeah, this can be null too, I think. We'll just kind of guard this as well. We'll just do this in kind of a hacky way.
Okay.
Imports is a reference to class declaration, array, or null. And this is null to start off with. Import expression is a TypeScript expression. Oh, is this? That is weird. This might be just something. Oh.
Yep. It's not.
And then if analysis imports is yeah, I think we can get away with better.
Oh.
Assuming that these things exist. Not calling our function. So now we can kind of count on imports be defined here.
Okay.
Data.
But why did we need those declarations on line 53, 54 then?
53, 54?
Yeah. Like
Oh, no.
used?
Okay.
Wow, we wrote all those types.
Yeah, skip registry there. Registry. Yep.
Okay.
Okay, so we've replaced this with kind of refactoring out the operations that happen when the imports are defined with this scope standalone imports. So that shouldn't have changed the behavior, but now we have this function that doesn't require the whole analysis in order to process them. Apparently we don't need the nodes for either.
How certain are you that this did not change the behavior?
I'm 90% confident we didn't mess anything up.
Okay.
I
mean, we'll see by the test later.
TypeScript is great for this reason, right? Because it it's going to check so much of this stuff for you. That as long because we got the types right here, right? I think that it probably will work. So now we can call this operation where we care about it. What directives and pipes are in there? Well, subscope, right, is scope standalone import, we called it. And so here we pass scope reader.
PTS, how follows things.
Reader, yeah, scope registry, meta reader. The compiler believes a lot in being explicit about dependencies. So now we pass just the imports that we care about, which is the imports flattened, and the raw imports expression, which is node, and use Parsing data.
Okay.
And we get back this thing called the subscope. So if we get back null, then we just skip it, right? So now we have subscope.directives. Awesome. So now we want to do essentially the check of, is everything in this directive set used? Let's
But if one of those things is a module, would it also return stuff or no?
So let's go ahead and make this bound get used directives map. Let's make a use directives set. Yes, if something is a module in there, then it will actually return, because we walk into the scope of the module and get all the directives from inside of it. I'm going to make a set from get use directives map.
And what's a binder and bound?
Oh, it's another one of my terrible names. The template binder, actually the thing you get back when you bind, this is a reference into an obscure compiler concept called binding. Basically, that is taking the nodes of a syntactic tree. So when you parse TypeScript code, you get this AST out of it. It's like a programmatic graph-based representation of the source code. And you have some identifier in that tree that says like foo. Is foo a class? Is foo a variable? Is foo an import, right? What does that node, what does that name actually mean in that particular location? And that operation is called binding. And so the bound template that we're working with here, or bound target, target being the template, is a kind of an oracle that allows us to ask questions like, what are the directives on a given element in the template? Or like, for a given expression in a template, like let's say you write, input value is foo, right? You can pass in this expression to get expression target, and it will tell you whether foo is a component or a property of the component, or whether foo was like some other element up here, like a div foo. Like it tells you where this expression is kind of pointing. So that's what the binder does. But we use it here because one of the things that is tell you what directives were actually used.
So it analyzes the component template, and it lets us, we can extract information of like which directives or pipes have been used in the template.
Yeah, cool. Exactly. So now what I wanted to do was basically create this use directive set, because I want to be able to implement this check. So what we want is if there are any directives in the scope that are not used, right, then we don't want to show the error.
So we're going to subtract them, or like we did before, I guess? Or no?
I'm going to use some, right? So if there are some directives that aren't used,
okay.
The use directive set has node. So if any directive in this list of directives in scope is used, at least one directive is used, right? No error. Here, then we've decided to produce the error.
Okay.
Now we can take our diagnostic that we make and add it to the diagnostics. And we have finally figured out what node to show it on. This is the node from the original loop that's going over the array here. Yeah, node and the elements. And actually, let's just, okay.
Okay.
So how lucky do we feel?
12% lucky? I don't know. What does the chat think?
Let's just make sure that our test is right here. So
50% says then.
50%. Okay, I like that confidence. So is not used. I think let's not fail for a stupid reason.
This is a simple test, just one. We're not testing edge cases.
Yeah.
So
not testing more than one.
That makes it 15% for me.
Oh, scared. Okay, let's try it.
I mean, that's the cool thing about typed languages, that they save you from
Yeah, we know it's gonna build.
Yes.
We'll still see failure because we have a fit test, right?
Okay.
So
why
you
did it fail?
the actual build test option to fail.
Oh, okay.
We passed.
Oh,
yes.
Okay. That
okay.
That's cool.
Let's make our test a little more complicated. Let's go for broke here, right? Let's add a directive called dir2. Use this one.
Okay.
So we should still see only one error. But we have to update our assertion because it's going to show this node. So let me just go ahead and let's run this.
Okay, the chat is very impressed.
I'm kind of surprised. Blah, blah, blah. Oh, we messed that up.
Okay.
I may have gotten, there may be something else. I'm not going to go down this route because I think there may be something else wrong in the implementation of actually matching the template that makes that not work. So let's not do that for now. With our passing test. I don't think that's the fault of the error system. I think that's the something else in my in progress state of standalone components.
You want to try the case with array of directives?
No, what I want to do, I think, is as I understand, we're close to time here. I just want to show you what the actual error looks like.
Okay.
So I'm going to comment out all the assertion stuff here. And I call a different compiler method on our test environment to drive main. What drive main does is essentially assert that something is a successful compilation, which it won't be because there's an error. But it also displays the error in the console to the author of the test as if it were actually TypeScript compiling it for real. And so when we run this, I'll make my terminal window bigger here. We should actually be able to see.
Okay. Oh,
this is not used in the template.
Nice.
Right. So this is the actual experience a user would have if they encountered this problem. Right.
That's cool.
Yeah.
Exciting.
Successful.
Yeah. I have a few questions from the chat. The chat is very shy today. I usually stream in Russian, so maybe it's a language thing, or maybe they're just overwhelmed. I'm overwhelmed. Lots of new things.
That was a lot. I'm impressed that we got through to actually have a passing test.
Yeah. So what the first question is from Daniel about the size of functions. He says they're big.
Okay.
What are your thoughts on breaking it up into smaller functions, or is this kind of the right balance which you found?
So I think it's important to draw a distinction between long functions and complex functions. I generally am okay with functions that are bigger or longer, as long as they are clear in the operation that they're describing, right? The function is doing one job, and the algorithm that the function is following to do that is straightforward, right? So I think a good example of that is this scope standalone imports function. It is quite the long function, right? It's probably, what are we looking at here? Like 100 some lines.
It's okay too.
But if you look at the actual algorithm imported, most of the function is a for loop. So we're operating on this imports array that we received. And we're kind of methodically checking, like, is it a directive? Is it a pipe? Is it an ng module? And performing a certain action in each case. And you could refactor these things out into kind of separate operations. But then you get into things like what we're doing is manipulating the scope object. So these map of directives and pipes, right? This is what we're trying to produce. And in the ng module case, we're going through the ng modules, exported directives, and adding them to this set of directives or pipes. If you refactored the ng module processing out into a separate function, you would then have either a case where that function would have to return like of things up, and you would have this kind of code way to post-process the result, or you would pass the maps into the function and then be mutating their arguments.
Yeah, which is not great.
Which is generally, not a good practice, not really good design. So sometimes actually the abstraction that you have to put into place to refactor out logic in certain places just kind of complicates and obscures the code more than just having more lines to read.
Yeah, makes sense. Also, like so many things and like multiple people working on it, so it's even if you abstract it out, it would be hard to reuse because like nobody will know about it. Which is, I guess, a problem for all big code bases.
Yeah.
Okay. So here, Coop is impressed. How do you find typos so fast? Easy to VS Code extension.
I mean, definitely, like the IntelliSense really helps, right? Like having this, getting the type information. I don't understand how people write JavaScript effectively without this. Like, I can't do it anymore after years of using TypeScript.
Yeah, that help. Spirit Hunter says, how can I start tinkering with ng compiler? Are there any good resources you can recommend besides your article?
Absolutely.
He says, besides your awesome article.
Thank you. Let me share a tab instead. So GitHub is a great way to view this, but if you go into the compiler CLI on GitHub,
let me show it.
Or go into the same. We were editing in annotations before, right? Each of the we try. Not all of them are as nice as others, but in each of the packages, we try to have a README.
Okay.
And the README describes kind of what the package is doing, how it relates to the other parts of the compiler, what some of the abstractions in that particular package are. So this describes kind of how incremental compilation works in the compiler.
Okay.
Which is one of the most complicated things I've ever worked on. And there's some funny stories of how this evolved there, but like basically each of the major pieces of the compiler's incremental implementation are described here, along with examples of how this actually works in practice. So if you're looking around the compiler code and want to learn how it's architected at a high level, those READMEs are a great way of doing that. Not all of them have them, like the partial evaluator here is missing one.
Oh, that's the most interesting part I learned today.
Yeah.
Yeah, we should have README.
If we look at the partial evaluator, right, it's kind of almost exactly what you would expect.
So does it like
implemented as a big if block?
Okay.
Right.
Oh wait, does it spawn some runtime, or it like literally like tries and evaluates it?
No, it literally tries and evaluates it. It's static evaluation, so it's not spinning up a JavaScript environment, right? It's not actually executing your code. We get an expression, and we say like, oh, is it the word true? Is it the word false? Is it null? Right? Is it a string?
Okay.
or text literal, then you get into things like, is it an object literal?
Mm-hmm.
Well, okay, if it's an object literal, then we do a bunch of processing where we know we're going to make a map out of it, right? With properties to values, where each value is kind of a descent into that part of the expression. And then you just handle all the TypeScript syntax for property assignments and short property assignments and spread operations and things like that. Notice here that in some cases we decide to produce invalid values, dynamic values. And
Dynamic.
one of the interesting things that dynamic value does is keep track of the reason why it was dynamic, why the compiler couldn't understand it statically. So in this case, this is a property assignment where the property name was not something we could understand. And that can happen when you have like computed property names and things like that. And so here we say that this was a dynamic value because one of the inputs to producing that value was a dynamic string that we couldn't understand. And then the compiler can actually give you a really that says like why it couldn't understand some high level thing because of some particularly lower level thing.
Oh. Do people often come with like edge cases where this doesn't work, or is it kind of pretty much stable now?
It's pretty stable now. People occasionally request kind of different things that like they would like to see it do, and we consider those on a case-by-case basis. One of the challenges is that this code also works in NGCC. NGCC is the compatibility compiler.
The view engine
NGCC's
one,
job
non-IB
is to, yeah. NGCC's job is to basically run against compiled TypeScript code, which is a lot more messy than running against the input TypeScript code. Because it's down leveled to ES5 or ES 2015 or something like that. And so certain operations that are like one line in the JavaScript code base are like many lines in one line in the source TypeScript is like many lines in the JavaScript output. And so the partial evaluator has to handle some like special things, which it only really sees when it runs against compiled code.
That's cool.
Yeah.
Okay, so that and also your very long comments on the functions.
Yeah, the README files are the way to go for understanding kind of different pieces of the compiler. Like Core here talks, this is kind of the really detailed version of my article, my blog post.
Talks
about how these pieces work. Template type checking is, I think, also one of the more interesting pieces. People were talking about that earlier.
Cool. Yeah, I think that's something we should look at separately. Are there like, if anybody actually want to go and contribute, are there like any small issues open where like just people from the outside can jump in and try to figure it out, or is it mostly for like people who?
I don't think we have a list of them, but actually the work we were doing today for adding error messages, right? Like improving error messages and improving in particular like the quality of the context of the error, telling you exactly what was wrong and why, is something that generally doesn't require too much knowledge of the whole machine, right? And can be really valuable and might be a good target for someone who just wants to kind of get their feet wet a little bit.
Basically find like a message you're not happy about and see how you can improve it.
Yeah, exactly.
That's cool. I actually got a message like a few days ago working on something and it like didn't make sense, and maybe I can jump in and see if I can.
So you've seen kind of how our testing framework works, right? We wrote a test for an error message. So the first step is to just make that. And even a pull request that does nothing to fix an error, but adds a test that clearly demonstrates it, is by itself really valuable, right? Because that gives someone else, maybe myself, maybe another person working on the compiler, a really good starting point for, okay, this is the exact scenario we care about. what better error can we show under these conditions?
Cool. So this question from me, sometimes you do want to like statically analyze some of the Angular stuff, and you actually want to get some answers. Like, okay, I want to look at this template, and I want to see like which directives it has.
Right.
Is that exposed in any way? So like as a library or like as a service, so other people can use it?
Not really. This is one of the things that we've talked about doing. I think we would be reluctant to do that without some kind of like data layer in between. So we wouldn't want to, for example, just say all of the compiler APIs and template like AST structure and all of that is now public, because that's what you really mean when it's like, is there an API for doing this? Is like, is there something stable that I can depend on that's not going to change, right? For asking about templates, you can always just load the compiler and use it to do that. So the like long term, I would like to see us have something like that, but it would probably be an API that's very much like you give us the template file and we give you a JSON object that describes all the directives. You probably wouldn't get access to like all of the compiler's internal information about it. There's a feature in the compiler now called extended diagnostics. And these are the checks that we're adding where the compiler thinks that you're probably doing something wrong. It will work. It's just probably not going to do what you think it's going to do. Let me see if I have the. This is the AIO page for it. The diagnostics. Type check. Extended. No Readme. But a good example of that is the invalid banana in a box.
Okay.
Check. So I'll show you the test because that's actually the good place to see it illustrated. So this is invalid banana in a box. Banana in a box refers to the two-way binding syntax of Angular. And the box are the brackets, right? And the bananas are the parentheses.
So we got the box and the banana here.
Yeah, exactly, right? So in Angular, the banana is supposed to be inside the box. The property bindings on the outside and the event bindings on the inside. What this means is we're binding to an event that has brackets in it. So the event is actually not a real thing with the brackets around its name. The DOM doesn't care, right? The DOM says your event names can be strings. You can have an event with brackets in it. But so this is kind of correct code as far as the compiler will do something with this that maybe you intended, right? But probably not. It's very likely that you just kind of typoed your banana in a box here. And so in that case, we actually show a warning. But we have this infrastructure called extended diagnostics, which is a way to kind of have extra diagnostic checks that are very standalone. So you saw that the code that we were editing was kind of like part of the core compiler operation of processing a component.
Yes.
The extended diagnostic checks are kind of add-on checks. So here's the code for invalid banana in a box. And so
it's like ESLint true kind of thing, right?
Yeah, a separate class with a particular API that's like, we just want to process some template nodes and look for, an event name that starts with open bracket and ends with close bracket. And in this particular case, we want to tell you like, this is two-way binding syntax. You got it wrong. And so these are warnings by default, and you can upgrade them to errors. And if you want like to run your compilation in strict mode. But this is another case where if you feel like contributing a diagnostic to the Angular compiler on top of the extended diagnostics API, that's another way to do it where you can kind of do it as a standalone thing.
That's cool.
And in this case, you do get access to And a better example of this would be the other check I think that we have right now, which is knowledge coalescing something that's not nullable. That's if you use the question mark like knowledge coalescing operator. But because we have a template type checker, we know the types of things, and if it's not nullable, then you didn't need to do that. And so here we have, this check is using the template type checker's knowledge of the template, right, to understand what the type of something is, and to make a diagnostic based on that.
All right. Do you have any test logic to catch any possible performance issues with the compilation time, etc., after pushing new changes?
Absolutely. So incremental compilation, right, which is so there's two, I guess, components to this question. One is like, how do you make sure that you're not just making the compiler really, really ridiculously slow? And we do test Angular changes against Google's code base, right? So any change, any commit that is made in Angular before it lands in the main repository has been vetted against, the many thousands of Angular applications at Google. And we do collect build metrics. So if there are major regressions in performance, they'll show up pretty quickly. So if you'll notice too, like the compiler has kind of two jobs, right? One is to produce correct output code. The other is to produce good errors when things are not correct in the input. And there are certain operations, a lot of things are structured in a lazy way, so that in the correct case, when we're trying to produce code and nothing is wrong, we do the minimum amount of work possible in order to produce that output. But when an error happens, like in our case, right? Actually, I will show you this on screen because I think it's kind of important to see that. When we did this error handler here, we're doing all of this work, right? To look over each input individually, evaluate it again, collect its standalone imports again, and then go through and check whether we need to make this diagnostic or not. I didn't particularly call it out in the beginning, but we did the cheap check, which used the information that we already had to construct a set of unused directives. And we used that as a guard around all of the rest of the work. And this is a philosophy, right? Which is, if there's an actual error, then nobody cares how long it takes the compiler to produce the particular error messages if something is wrong, right? So we can do more expensive things to make errors than we should do to make the compiled output. And so this is kind of like, we check very quickly a problem. There is a problem, then we can spend a lot of time, right, that we might not otherwise do, figuring out the best way to tell you about the problem.
That's cool.
The second kind of aspect of this question is for, in particular, we care a lot about the rebuild performance in the compiler. How long it takes when you make a change in a hot compilation when you've already built once, to figure out the effect of that change and apply it and generate new output. This is the like ng serve scenario. And we do have tests for that particular case. I don't remember incremental spec, I think. Yeah. Very important test here that verifies we don't crash.
Sounds useful, yeah.
Yeah, should not. Yeah. So a lot of these tests are concerned with making sure that the compiler does not do work that it doesn't have to do. And that's one of the ways that we make sure performance is kind of stays good over time.
Mhm.
Is we have tests that actually encode like these are the operations that we know need to happen to build a particular piece of code.
Mhm.
And if the compiler does more than that, if it does things that it shouldn't have to do,
Mhm.
then the test fails.
Mhm. So it checks like, oh, this has not been done, basically.
Yeah.
Mhm.
So at the end of this test, there will probably be assertions that like,
Not contained
yeah,
your JS, yeah.
we didn't emit the directive.js, right?
Mhm.
We did not touch this file because it didn't need to be touched. So the compiler did no work related to producing directive.
Mhm. Makes sense.
Yeah.
So there are many like a new wave of libraries where people rewrite stuff from JavaScript to Rust or like Go or like faster
Yeah.
languages. Have you considered doing that?
Oh, I'm in my IDE. Hang on. Switching between sharing screens.
Oh, yeah. You're opening Angular 3. Okay.
So
Okay.
it's a private GitHub repository. I haven't published this code anywhere.
Uh-huh.
But one of my hobby projects, kind of outside of work,
Mhm.
is building an Angular compiler in Rust.
Okay. The question was literally about trust. So
Yeah. Let's see what's a good, interesting thing to look at here. Yeah, there we go. This one. So, parsing Angular templates.
okay.
We have HTML parsing element start, element end.
Mhm.
We also have somewhere here. I think we have mic syntax. Yeah, there's a lot of different pieces to processing Angular, but I
Mhm.
generally believe quite strongly in like build tooling should not be written in JavaScript.
Okay.
JavaScript is just a terrible language performance wise for doing the kinds of things that you need to do in a compiler.
Mhm.
So
So how is your experience with the Rust? Do you kind of feel like it is much faster?
it's I haven't gotten far enough
Mhm.
to really like be able to do an apples to apples comparison.
Mhm.
But it is definitely uh, for the operations that I have implemented, screaming fast.
Mhm.
Um, and actually, my compiler is capable right now of producing smaller code for some templates than the main Angular compiler,
Mm.
because I was able to leverage some of like Rust capabilities to do more advanced optimizations in the output.
Mm.
Yeah, just a fun little thing I've been playing around with.
Cool. We just got a raid from Kostishko. 5 people. Thanks for the raid. All right. Yeah, everybody follow Kostishko. He does game development, I think,
Oh, that's
in
awesome.
Russian. Yeah. Have you done much like Twitch, watching dev stuff on Twitch or anything?
Not really. So I've watched a couple of like Rust streams on YouTube,
Mm-hmm.
but not much on Twitch.
Cool. But do you think like this Rust thing you're trying to make it like get it to feature parity and try to make it an official thing, or is it more just like learning
It's
thing?
it's more for my enjoyment because
Mhm.
I like working in Rust and it gives me kind of a more complex project to do.
Mhm.
Um, I don't think I'll get it to feature parity. That would be a massive investment of work. But I
Mhm.
would like to get to the point where I can do a good enough performance comparison to really
Pitch
like
it.
to have an understanding of what's the upside here? Is this valuable to invest in?
Mhm.
And like it would be cool, for example, if we could then take a small piece of the compiler, like the template parser.
Mm-hmm.
Say, we're going to just implement this particular piece in Rust.
Mm-hmm.
Something that is really performance critical, right? Parsing text is kind of expensive.
Mm-hmm.
And then maybe compile it to like WebAssembly,
Mm-hmm.
right? And we can use that in Angular's JIT implementation. And then in the AOT implementation, we can load it as a node module with like native node module bindings.
Interesting.
So there are ways in which you could conceive of like pieces of the compiler being transitioned to Rust, even if the whole thing isn't.
So
One of the big challenges, right, is we're a TypeScript based project,
Mhm.
the TypeScript compiler, and that exists in JavaScript, and so we can't go beyond that.
Mhm.
If you still want to have template type checking, you have to be using TypeScript's compiler.
Right.
But there may be cases where we can accelerate certain parts of operations
Mm-hmm.
that happen in Angular.
Yeah, basically just pick the slowest one and make it faster.
Yeah.
So it will be like micro compilers, like microservices.
Yeah. Another one of the questions I want to answer is a Rust-based compiler built into WebAssembly
Mm-hmm.
larger or smaller from a code size perspective than the equivalent JavaScript bundle?
Mm-hmm.
And so far, it's way too early to tell.
Oh, it's like technically you could have Angular written in Rust and then shipped to the browser through WebAssembly.
Yeah, you could. One of the things missing in WebAssembly at the moment is any kind of direct interaction with the DOM, which means that in order to do DOM operations, you kind of have to go through the WebAssembly to JavaScript boundary.
Yeah.
And the Angular runtime is effectively like it's a state machine for updating the DOM. And so moving that to WebAssembly would make zero sense. So WebAssembly can directly talk to the DOM. Then it might actually be a really viable thing to do.
You know if that's coming?
I know there's certain designs floating around. I don't think there's anything yet like directly on a standards track.
That's kind of a very similar problem to web workers, where you can run Angular in a web worker, but
yeah.
Cool. Okay, chat. Any more questions? Otherwise, yeah, that was very interesting. My favorite thing is the evaluation thing. That's pretty cool.
Yeah, that was a lot of fun to work on.
Okay, everybody's saying thank you. All right, thanks a
Thanks
lot
for having me. This
Alex.
was awesome.
Yeah, that was fun. And have a good day, and bye everybody.
Cheers.